Here we have a phased array of transducers emitting sound that passes through a nylon mesh. This mesh absorbs some of the sound and heats up as a result. The mesh is imaged using thermography, and with this we can derive in near real time the incident pressure field on the mesh. This paper demonstrates this and uses it to create a new camera-in-the-loop holography technique. The first part of this paper covers thermography. As the sound is turned into heat in the nylon mesh, it spreads out across the material. We must therefore account for this and other factors when converting temperature into pressure. In order to convert this temperature into pressure, we need to both calibrate and validate this method. We do this by taking some microphone measurements to use as our ground truths for training and validation. We achieve an average peak error of 2.2% and an average 2D error of 62 pascals. Now we shall look at creating a new holography technique utilizing this thermography technique. Traditional algorithms for ultrasound holography iterate between transducer states and the simulated hologram. In our process, we then send the final phases from the phase retrieval algorithm to the device to measure the hologram. We then change the target field that is input into the phase retrieval algorithm and iterate until the measured hologram is equal to our target. This process is enabled by the quick measurement time of our thermographic technique and therefore accounts for differences between simulations and reality. Here is 16 focal points with a target of 1100 pascals with the base algorithm. Here is our process. It is clear to see that our version is closer to the target with a mean pressure of 1071 pascals compared to 961 without the camera-in-the-loop method. As future work, it could even be possible to measure non-static sound fields. In conclusion, we show a method for more accurately reproducing target holograms, as well as enabling rapid measurement of high-pressure sound fields. This enables the generation of bulk datasets for training machine learning-based holography algorithms additionally.